sure you got it.
Alright, IrVision. FANUC's vision system. There are other vision systems out there. This is FANUC's. There are some definite advantages to this over other vision systems when dealing with FANUC robot. So this is just kind of an overview of some of the things that we'll learn about the vision system related to FANUC anyhow. Every R30IB, which is our controller in this robot, every one of those controllers is vision ready. What do you think that means?
It has the software.
It has everything there ready to plug a camera into it. So there's no...
Doesn't it have a camera?
This one already has it, yes. But every controller, if you buy the controller, even without buying the camera to begin with, and you decide, hey, I want to add vision to it, all the hardware and software and stuff is there. It's ready to connect a camera to it. Okay? Every one of them comes vision ready. I believe the R30IAs are also vision ready. There are some differences about it that we'll talk about. So no dedicated computers required. You don't have to have a computer. You can use a computer to program it, but it's not required in the version B. Setup can be done from the teach pendant, so we can grab our teach pendant and do all of the programming of the vision system right from the teach pendant. Okay? Obviously, if you have somebody else's software or somebody else's camera system, that's not going to be possible. Okay, so that's a definite advantage. Or we can use a computer. We'll show you both. We'll let you set it up using a computer, let you set it up using just the control or the teach pendant controller, and show you what the difference is. Okay? Some things I think are easier just because it's bigger, easier to see on a computer. Less hardware to purchase versus the R30IA. The R30IA had to be controlled from or set up using a computer. Once it was set up and programmed, you didn't need the computer anymore, but it required a computer. A lot of the stuff that you can now do right from the teach pendant, you couldn't do from or with the teach pendant on the RA, on the A version. Okay? And of course, if it's from a different manufacturer, you're going to need a lot of extra hardware and software where it's all built right into the FANUC. It's designed to offset robot position based on part movement. So if a part comes in and it's not in the exact same orientation, it can still find it and still pick it up and do an offset. The robot will do an offset to know where that part's at. And that's kind of the whole purpose of the vision system. It is useful for part recognition or inspection. It can also be used if you've got a part coming in and you just want to look at it and see if it's good. Look at certain holes or certain pattern or something that's in or on that part. It'll do that also. It'll look at that part and determine if it's just a pass-fail, kind of, yep, that's good, or it's not. So you can use it for inspection where you really don't have anything to do with the robot, per se. Okay? Maybe you don't want the robot to pick it up, you just want to know if it is a good part. It can be used for that. The vision process executed from the main robot, no separate processing hardware needed. So you don't need to have an extra computer, you don't have to have another cabinet. With some vision systems, you have to have a whole different cabinet for the vision stuff. This is all built in. So that makes it kind of nice. These are some of the things we can use them for. Here we're using them to cast a part on a conveyor. Hey, there's a conveyor running. It can find the part on the conveyor. It can either stop the conveyor and grab the part, or it can grab it on the fly. Depalletizing, what do you think that means? Unpackaging stuff. Stuff comes in on a pallet. You can use the robot to grab it off the pallet. If it's 3 deep, the robot has to know, hey, I need to offset so many millimeters and go down and get the next one. Or I have to offset in the X or the Y location to get the next one. Okay? And the vision system can look at that and determine how far over it has to go, so you don't have to do a lot of programming. Program the first one, and everything else after that is just an offset from what the camera sees. Vision tracking of food products, or it could be any product, and that's moving on a line. Okay? The line don't have to stop. You can take a picture of it and know exactly where it's going by how fast, knowing how fast the conveyor is moving. Metal stamping, handling pieces that are stamped. Airproofing. Here they got a cassette. Is the thing in the case correctly? It's just taking a picture of it, and it really maybe the robot's not even picking it up, but it's looking to see if everything's good with it. Okay. Bin picking. I think that is picking things up out of a bin. Takes a picture of it and can determine where it is that it needs to pick it up. Transferring of glass sheets, could be any kind of sheets. Maybe it comes in on a pallet and it has to know, I'm going to get this piece and now I've got to go down just a little bit further to get the next one. Or if they come in different positions, the vision system can look at that and determine exactly where it needs to pick them up. And locate different parts. Here they've got a tub and they're putting a jet or something into it. Well, where exactly is that hole, and where does it have to stick it in to hit that hole? So all kinds of different applications that you can use the vision system for. Airproofing, again, it's a cost-effective approach to check for the absence of something or that something's there. In this case, they're looking at exactly where the hubs of this cassette's at. This one, if you can see that, at the bottom it's red instead of green. Green pretty much is, hey, I passed, everything looks like it's where it's supposed to be. Red is, something's wrong there. Well, the cassette's in there backwards. So it would know that and flag that, hey, that's a bad one, something's wrong with that. So, and it could be any part. If you're looking for, hey, I have so many holes, or they're oriented in such a way, or they're so big, the vision system can pick all that stuff up. 2D single view process. It's a 2D process versus a 3D process. So it's only looking for half, really, of the movements that a robot can do. Okay? It's looking for X, Y location. So you can go your X and your Y location. And it's looking for roll of the wrist. Okay? So if it's picking up an oblong part, it has to know exactly how it's positioned there and its X and Y location. Okay? So it's a 2D single view process. Single view meaning it's only snapping one picture, or it only has one camera, one or the other. It's accomplished with a single camera. Okay, in this case, if you can see this, the camera's mounted right on the robot. Ours is not like that. Ours is a fixed mount, but they have them that are mounted right on the camera, so mounted right on the robot, which is kind of nice. So you can move the robot to wherever you want, snap a picture, and then send the robot after whatever it's after. So it can be attached, can be fixed mounted, and it can produce X, a Y, and a roll offsets. So you'll program your very first part, and everything else is relative to that. How many millimeters is it off in the X direction, Y direction, or the roll direction? We can also have a fixed mount, where this one isn't connected to the robot itself. It's just fixed mount. That's the way ours is. Here's your whole system. You've got your robot, your control cabinet, which is a little different than ours. You've got your teach pendant, and you can have a teaching PC. If you got the older A version, you have to have the computer to program the teach the vision part of it. Okay. Once it's taught, you can take the computer off. You don't need it anymore for production. But with this system, the IV system, you really don't have to have a computer. You can have, if you want. You can do it either way. You can do all the programming through the teach pendant if you want to. Multi-view. A couple different ways you can do multi-view. You can have two cameras. Why do you think you'd have to have two cameras? Two fixed cameras on this one. Why?
So you can get the height of some object.
No. It's still just 2D.
To be more accurate.
No. Kind of. What are we going to be picking up or looking for? What if it's a huge part? What if it's 3 foot long and it can't fit in the field of view of that camera? And it has to know both ends. Okay? So if you have larger parts that one camera can't pick up because it's just too big, can't fit in the field of view, it'll merge the images of two cameras together so that it sees the whole part. Okay? It's accomplished with one or more cameras. How's it going to do a multi-view with one camera?
Put the camera on the arm.
It could be mount it on the robot camera and take two different pictures and merge them? Or what if it's on a conveyor and the part's moving past it? It can snap more than one picture with one camera. For parts too large, again, for a single camera, for single cameras, it takes pictures in multiple locations. So someone's got to move that camera or move the part, one or the other. For multiple cameras, cameras can be fixed or robot mounted. Okay? At the training that I was just at, we had both. We had a fixed mounted and a robot mounted camera. Again, it's going to produce an X, a Y, and a roll type offset. Okay? Offset, of course, just being how far is it from where I programmed it. I programmed it to pick up the part right here, but now it's over here. It has to know how far over it is. Okay? 3D, we don't have this here yet, anyhow, but it's an option also. It has a normal camera, same kind of a camera, but it also shoots a laser down at it and hits it to get the 3D effect. Now it can do X, Y, Z, yaw, pitch, and roll, all of them with the 3D system. Okay? If you have to know the depth of the part, and it can vary, you'd have to have that kind of a system. Okay? At some point we may get into that, but right now we don't have that hardware. Okay? Visual tracking. You got a line that's got parts running down. You don't want to have to stop that line. You want the robot to be able to grab stuff right off of that line. You'll need something that's doing visual tracking. It can detect the part moving on a conveyor. It adjusts the robot to pick up that part as it moves down the conveyor. That's what visual tracking is going to be. Okay. To do that, of course, we need to have a camera. These are some of the more common cameras used for the FANUC robot. This is the one that we have. The Sony XC56 camera is the one that's on this robot here. Okay, so we've got the camera and we've got the lens that's on the camera, and the lens is going to be determined by how far away that part is, the focal length from the camera itself to the part that you're going to be picking up. Okay, it's a standard type camera used in industry. The Geeky camera is an internet or an IP based camera, so it's a little bit more expensive. Advantages of the Geeky camera we'll get into. If you get high resolution, you do have to watch the amount of memory that you have in your controller. Okay, it needs a little bit more memory than the Sony type cameras. But the Sony's the one that we have, so that's the one that we'll mainly be concerned with here. With the Sony type cameras, if you have more than one camera, so if you want to do multiple cameras to look at a part, you have to have a multiplexer. What's a multiplexer do? We've already learned that. What's a multiplexer do? Okay, you have multiple inputs, multiple cameras, but you only have one thing that it's feeding it to. It's only feeding it to one controller. So you'd have to have a multiplexer board in that case. Okay, this one has a spot for 4 different cameras. So you've got 4 cameras that could plug into the multiplexer ports here, and then 1 port that would plug in from the multiplexer board back down to the control cabinet. Okay. The Geeky cameras are Ethernet based again. They're a little bit more expensive, but if you want multiple cameras, you don't have to have a multiplexer board, because there are very easier methods of doing it. What do we use if we want multiple Ethernet connections to one Ethernet connection? What do we use for computers? We could use a router or just a switch. You can buy them for $39 at Walmart, probably. Right, Carl? Probably. Okay. So it's in that respect, as far as adding a bunch of cameras, it's probably cheaper in the long run, maybe, to go with the Geeky camera that are Ethernet based. But if you only want to have one, the Sony camera is a cheaper method. If you only want one, you could use a Geeky. There's ports on the controller to plug in Ethernet type cables also. Okay, teaching computer. You may or may not want to use a teaching computer with this IrVision. You can do it all right from the teach pendant, or you can use a camera, or you can use a computer to control the camera, or to look at the vision system. Okay, so it's kind of optional with this. With some of the older versions, you had to have the computer to do the programming, and then you could take the computer off once it was programmed. Calibration grid, what do you think that's used for? To calibrate. It's used to calibrate the camera. Okay? Extremely important piece of plastic. Let me see if I can put my hands on ours real quick. Here's our calibration grid that we got with our camera, or with our vision system. Pass that around if you haven't got to see it yet. It looks very similar to this. The spacing's a little bit different. I think that's a 30 millimeter. Say 30 millimeter at the bottom. That's the spacing between the center holes. Okay? Every one of them is going to have its center to center holes listed on it. This one is a picture of a 15 millimeter grid. Okay? But it does allow us to calibrate the camera. If the camera knows exactly how far it is from one hole to the next when it takes a picture, every time it takes a picture after you've calibrated it, it knows exactly how far things are, so that if you have an offset, it knows exactly how far to move to go get it. Okay? So there are various grid sizes based on the field of view of your camera. Okay? So if you got a bigger part, smaller part, that could dictate what grid spacing you want. Okay? They go from 10 to 40. Ours is a 30. Okay? The four large circles, these four circles in the middle, have to be seen by the camera to calibrate. The rest of them, it's nice if it can see them, but those four have to be seen so that it can pick up the X direction, which are the 3 circles, and it can pick up the Y direction, which are the 2 circles within its view. Okay? So it has to see those. It's best if it can see them all to set up the grid, or to set up or calibrate the camera. Okay? The grid itself should be on a rigid backer. Look at it right now, just laying on the bench. Ends are flipped up. If the camera looked at that, it's going to see that in a 2D world as one of them dots maybe being a little closer than it really is. So we'll have to put that on a piece of steel or something to give it a nice rigid back so that it's perfectly flush and flat. Okay? So you don't want them all curled up like that. It's a sticker basically, so we can stick it on whatever we want. Okay? So the warping of it would definitely affect the accuracy. Okay? If you want it to be as accurate as possible, you want to refrain from that. This is what it looks like when we connect the computer to the CPU of the FANUC. It's just an IP based, so we'll use Internet Explorer, go to the IP address of the controller, and we can talk to it that way. So it communicates through Ethernet. It's the only way it will communicate. Okay, so if we want to hook the computer up to it, this is what we'll see. We'll see the web server of the robot. There's a lot of criteria there as far as turning off some things and turning on settings and stuff for Internet Explorer. And we'll go through all that as we go so that you can set that up. Okay? Sometimes it can be a little hairy to get all those settings right so it can communicate. Teach pendant, used to teach the vision system. You can teach the whole thing. I know this vision or this teach pendant's a little bit different than ours. This is an older version. But with ours, we can do everything right from the teach pendant. Okay? Run time, you can watch it run, watch it snap the pictures. All that can come up right on the teach pendant, and you don't have to have a computer. You can have, but you don't have to. Okay? Questions? None? You're all geniuses at it now? Got her bastard done. Again, that's just kind of an overview of what we're going to learn about it, how to set the thing up and snap pictures and use that offset to move the robot to a different location. That's it.